Good morning, students. Welcome to video lecture on microwave and optical fiber communications. Subject code U18EC709. Topic: major elements of an optical fiber. Introduction. In optical fiber communication, visible light and infrared lights are used. Infrared light covers a fairly wide range of wavelengths used for fiber optic communication. Here you can observe the wavelengths of electromagnetic spectrum for visible light and infrared light. The wavelength of visible light falls in the range of 700 nanometer to 400 nanometer. For 700 nanometer, it is a red light, and around for 600 nanometer, it is yellow. Around for 500 nanometer, it is green. For 400 nanometer, the color of the visible light is blue. And mostly for optical fiber communication, infrared lights are used for different windows of optical fiber communications. The first one is 800 nanometer window, and the next is 1310 nanometer window, and the next is around 1500 nanometer. These three windows are mostly used for optical fiber communication. And now, once again, just go through the spectrum of UV rays, visible light, and infrared light. The infrared spectrum ranges from 700 nanometer to 1 millimeter. Here, the infrared frequency is around 3 terahertz to 430 terahertz, and visible light frequency is around 430 terahertz to 800 terahertz. But when we speak about optical fiber communications, our discussion should be on wavelength. In case of microwave communication, our discussion should be in terms of frequency, that is in gigahertz. Need for optical fiber communication. Optical fiber communication system has emerged as most important communication system. The first advantage is uh, they are useful in long haul communication system. There is a need for low loss transmission. For long distance communication, the low loss transmission is desirable, so optical fiber communication is needed for long distance communication. Next, need for compact and lightweight transmitters and receivers. Lightweight transmitters and receivers are available in optical fiber communication system when compared to conventional communication systems. Here, uh, need for increased span of transmission is available in optical fiber communications only. And here, high bit rates are available in optical fiber communications. Just go through the need for optical fiber communications. The next is major elements of optical fiber. Uh, the major blocks of optical fiber are transmitter, regenerator, amplifier, and receiver. Transmitter, receiver, regenerator, and optical amplifier. Here, the transmitter will convert the electrical signal into light. It is the driver circuit, and light source can be either LED or laser. Uh, and the light will come out of the source, and it is connected to the optical fiber cable. The signal will be transmitted through optical fiber cable based on the concept of total internal reflection. And here, uh, the other blocks are required for optical communication are optical fiber connectors. They are useful in short distance communication, and optical splice. They are useful in long distance communication. Optical splice is a permanent joint between two fibers, which is useful for long distance communication. And here, for short distance communication, like communication within the building, uh, connectors are used. And the next block is a regenerator block. Let us say here this is the signal transmitted, and after traveling some distance, it may gets distorted uh, to gets to its original shape. Regenerators are used so that at the output of regenerator you will get the signal which is transmitted originally. And the next is optical amplifiers. The optical amplifiers are used to amplify the signal strength. After traveling some distance, the signal uh, gets distorted. That can be recovered with the help of amplification of the signal. And here the receiver, the next is the receiver block. In the receiver block, the basic elements are photodetector. The photodetector can be either avalanche photodiode or pin photodiodes are used, then followed by amplifier, then followed by signal restorer. At the output, you will get the electrical signal out. Just go through the basic components and additional components. Just now we discussed here uh, the transmitter generates the electrical signal, the receiver receives the optical signal. Here, after traveling some distance, the pulse broadening is taken place. Pulse broadening and other dispersions can be taken care by regenerator circuit. You can observe how the signal is transmitted and how it is received at the receiver. Just now we discussed about transmitter, light emitting diodes and laser diodes are used for transmission. Just go through the difference between laser and LED in terms of cost, data rate, distance, fiber type, lifetime, temperature, sensitivity. The cost of LED is low, laser high, data rate is low in LED, data rate is high in laser diode. LEDs are used for short distance communication, lasers are used for long distance communication. The reason is they are more chromatic, and laser signal can transmit, sorry, laser signal can propagate for a longer distance. And regarding signal transmission, LEDs are used in multimode fibers only. Lasers are useful in both multimode and single mode fibers. The lifetime of LED is high and the lifetime of laser is low. The temperature sensitivity, the temperature effect on LED is minor, and the effect of temperature is significant in the case of laser. You can observe how a single mode fiber means single uh, one signal transmission through the optical fiber, how the signal is transmitted. In multimode fiber, you can transmit a number of optical signal based on your application. You can observe the signal transmission in single mode and multimode optical fibers. It is the receiver block we just now discussed here. This is a position of transmitter and this is the position of receiver, and it is the optical fiber, cable system and other circuitry. You can observe the height of pulse at the time of generation, it is high, and after traveling, after reaching at the receiver, the height of the pulse is decreased. This can be taken care by incorporating optical amplifiers in between so that you can achieve long distance communication. Just go through the points, and here in receivers the noise consideration is uh, an impact factor in receiver design. And another important performance criteria for optical receiver is average error probability. Uh, we already discussed information channel, optical amplifiers boost the power levels of weak signals. Amplifiers are needed in long links to provide sufficient power to the receiver. The very important information about optical receivers is uh, with the invention of erbium doped fiber amplifiers, they are majorly used in third window. In first and second windows, uh, the losses are very high, and in third window the losses are less. And the major advantage of third window is erbium doped fiber optical amplifiers are available only in third window. Regenerator transform the degraded bit stream into its original form by performing the operations like reamplification, reshaping and retiming. At the time of transmission, this will be the transmitted signal, and after traveling some distance, the signal gets degraded. That can be taken care by regenerator. Optical windows, there are primarily three windows. The first one is 850 nanometer, the next is 1300 nanometer, and the third one is 1550 nanometer. Multimode fiber is designed to operate at 850 nanometer and 1300 nanometer, while single mode fibers is optimized for 1310 nanometer and 1550 nanometer. You just correct it, 1310 nanometer. In general, multimode fiber uses LED as source and single mode fiber uses laser as source. Once again, go through the spectrum of visible light and infrared light. The specified losses per kilometers in dB per kilometer for different windows. For 850 nanometer window, the loss is 1.5 dB per kilometer, and for 1310 nanometer, the loss is 0.40 dB per kilometer, and for third window, it is 0.25 dB per kilometer. You can observe the loss or different attenuation levels are decreasing when you are moving from first window to second window and from second to third window. The major advantage of, once again I am repeating, the major advantage of third window is erbium doped optical fiber amplifiers are available in this particular window only. uh, just now we discussed about what is the problem of 800 nanometer, and the propagation losses are more in 800 nanometer. Uh, the next is 1310 nanometer window is somewhat better compared to 850 nanometer, but still the erbium doped fiber amplifiers are available in 1350 nanometer. For that reason, we are majorly present day we are using third window. You can observe the attenuation in different windows. It is the first window, second window, and third window. The losses are decreasing. Advantages of optical fiber communication. Just go through larger bandwidth, long distance, faster speed, higher resistance, and greater security. Dear students, just make a glance the physical advantages of optical fiber cables. Just go through. And some application areas of optical fiber, medical applications, in internet, in lighting and decorations, in mechanical inspections. Just make a glance. Thank you. We will meet with the next lecture.